Hello everybody, welcome back to another video, and in this video we will be learning about recursion in Python. So let's begin. So we'll dive into the world of recursion, which is a powerful programming technique that can simplify complex problems. We'll explore how recursion works, and we'll also learn about potential pitfalls like stack overflow errors and the memory management concepts involved. For example, stack memory and heap memory. We'll also learn the difference between tail recursion and head recursion, along with practical coding examples. Okay, guys. So first of all, let's talk about what is recursion. So recursion is a programming technique where a function calls itself. So the function breaks down a problem into smaller and similar subproblems. Each subproblem is solved using the same function but with a smaller input value. This process continues until a base case is reached where the function doesn't call itself anymore and returns a simple result. So every recursive function needs to have a base case to prevent the function from calling itself over and over again infinitely, okay? So think of recursion like a Russian nesting doll. Each doll opens to reveal a smaller doll with an identical in structure but smaller in size. Recursion works similarly, breaking down a problem into smaller versions of itself until a base case is reached, the smallest doll that provides the final answer. So let's talk about the power of recursion. So recursion excels at solving problems that can be naturally divided into self-similar subproblems. Examples include factorial calculation, uh, maze solving algorithms, or so on and so forth. So recursion shines in scenarios where the program exhibits a self-referential nature. For instance, calculating the factorial of a number involves multiplying it by the factorial of the previous number. Similarly, traversing a tree structure involves visiting child nodes, which themselves might be subtrees, leading to recursive calls. So now let's talk about stack overflow errors. So before we actually talk about stack overflow errors, let's take an example of a recursive function. Let's take a factorial. So actually, before we begin, I just want to show you something that whenever we, you know, um, do something like in a recursive function, the it is stored like inside the stack, and if the stack gets filled, then that will lead us to a stack overflow error. So listeners, say we do something like define and then factorial calculation underscore calculation, and this will take one parameter, which will be n. And now what this will do, now in this first we'll have our base condition. So if n is 0, we're just gonna do one thing. We're just gonna return 1, right? And that's it. If it is not 0, what we're gonna do is we're gonna do n times the factorial calculation of n minus 1. Okay, so now let's find the factorial calculation of 5. So first of all, I'm just gonna, bring up iTerm. Okay, so I'm gonna go into my folder, and I'm just gonna in here say Python factorial.py. Okay, so line repeated n minus 1 int and n type. Let's see what we did wrong in here. Okay, so let's see. Okay, that should be return. If I do that and rerun it. Okay, we actually have to print the factorial calculation out. So, print, let's say the factorial calculation of 5. So if I do that, go back and run it, and as you can see, now we get 120. So let's see why we're getting 120. So first, we're seeing if n, which is 5, is 0. It's not, right? So we're just going to skip it, and we're going to this line, else. What we're going to do is we're going to multiply 5 times the 5 times 5 minus 1, which will be 4, okay? So then it's gonna go back to the base case, and we'll see that the base case is still not hit. So then it will just go back again, and now it will become 4. And now we'll do 4 times 3 4 minus 1, which is 3, and then it's gonna go back up here and see if 4 is 0. It's not. So then now no, it's gonna see, yeah, if 4 is 0, it's not. Then it's gonna do 3, and then times, and 3 minus 1, which is 2. It's gonna go back up there. It's not. Okay, so then it's gonna do 2 times uh 2 times 2 minus 1, which is 1. It's still not hit. Okay, so then it's gonna do 1 times 1 minus 1, which is 0. Then now the base case is hit, so then it's gonna return 1. So that is what's going on. So if we do not put this base case over here, so if I remove the base case and run it again, okay, now we run into an recursion error. It says the line repeated more than 996 times. So so it did n times the factorial. So it just kept going. Also, it went into negatives. It went to negatives or something like that, and then the line was repeated again and again, and this is in Stack Overflow error. So it was just the stacks were keep getting added into the stack memory, and the stack memory couldn't handle all that. So that's why we ran into this Stack Overflow error. So that is why every recursive function needs to have a base case. So let's talk more about Stack Overflow errors. So I'm just gonna wait. Where's my Okay, so over here. Okay, so a potential issue with recursion is Stack Overflow errors. Every function call in a program requires memory allocation on the stack. The stack is a fixed size memory area used to store function call information, for example, local variables, return addresses. Excessive recursive calls without a proper base case can exhaust the stack space, leading to Stack Overflow error. Okay, guys. So imagine a stack of plates used in a cafeteria. Each plate represents a function call. Recursion adds another plate for which, let's just say the another plate is a function call on top of the stack with each iteration. If the number of recursive calls becomes like very large and the base case isn't reached soon enough, the stack overflows, similar to a stack of plates crashing down. Okay, so now let's talk about memory management in recursion, stack memory versus heap memory. So recursion involves memory management for the function calls. Two key memory areas are involved. Stack is a fixed size memory used to store function calls, as I mentioned before. Data gets pushed or added and popped in a last and first out LIFO manner. Dynamically allocated memory space used to store objects created during program execution. Memory is allocated, deallocated as needed. So recursion is, you know, recursion leverages both stack and heap memory. The stack manages function call information like local variables and return addresses. The heap, on the other hand, is used to store objects, data structures, created with recursive functions. It's important to understand how data is stored to avoid memory related issues. Okay, so now let's talk about tail recursion and then head recursion. So, tail recursion is a specific type of recursion where the recursive call is the last operation before returning. So let me give you an example over here in VS Code. So I'm going to say def and then tail. So then this will take one parameter, which will be n. So in tail recursion, so the recursive call will be last. So first, let's just do our base case. If n is 0, we're just gonna return 0. Return 0. So if it is not, we're going to first do the operation, which will be printing n. So I'm just gonna put like a hash over here. Do the operation print, and we're gonna print out n. And then now we're gonna do our recursive call, which will be tail and that will be n minus 1. And now I'm going to say tail of 7. So I'm just going to go back in iTerm on that, and as you can see, it goes down 7, 6, 5, 4, and so on. Okay, so this is an example of tail recursion. So again, this is tail recursion because, as you can see, the recursive call is last and the operation is before the recursive call. So now let's take a look at head recursion. Okay, okay, guys. So wait one sec. Okay, so the head recursion, unlike tail recursion, is not the that is not last in the function. Isn't doesn't do the recursive call last. It does the recursive call somewhere in the middle of the function. So let me give you an example. Let's say def head, and this will take one parameter, which will be n. And let's do our base case. So if n is 0, we're just gonna return 0, or else first let's just do our recursive call, which will be head n minus 1, and then now we're gonna now do our operation. So do the operation. So I don't need that. Okay, so print, we're gonna print out uh n. Okay, so now I'm gonna say head of 7 again. So run it, and now, okay, now this time is going 1, 2, 3, 4, 5, 6, 7. Unlike tail recursion, because the recursive call is in the middle. Okay, guys. So yeah, okay, guys. So I think that's pretty much it for this video. Thank you guys very much for watching. Make sure to smash that like button. Make sure to hit that subscribe button, and I'll see you guys in the next video.